Hi, hello, I'm Neil Millard. Welcome back to another episode of Chaz. Can we, or can I, create a container hosting system? So this is where I left us in the last video. We've got our README with our components, and it makes sense for us to talk about nodes. Specifically, we're going to talk about the agent that runs on the nodes. So with that, I've created this components folder with an agents folder in it because we're going to have the API as well as our agent. And we want several bits in our agent. So the first thing that I've designed, because before we let AI or anything else anywhere near our code, is we want to have a design in mind. So I'm going to use nerdctl as part of, as it says there, the Docker replacement. We could, using Python, create our own library that then talks to containerd on the local machine, or rather on the node. But that's a lot of work. We want to do a minimum viable product, which means we want to do the smallest amount of work required in order to get this thing working. So with that aim in mind, we're going to use the nerdctl to talk to containerd, and we need the agent to talk to our API. Our API will be responsible for keeping all of the data together and maintains the state of the containers and the host they run on, as it says here. So in our design, we need some data objects that we're going to work with. So the first decision, if you like, is how the agent and the API are going to talk to each other. And so the API is very used to receiving requests. So it makes sense for our agent to send a request to the API to say, hi, I'm an agent, what do you want me to do? And then it can do other stuff after that. But let's focus on the first thing it's going to do. So it's going to report what the capabilities of the agent are inside a register request. So if you've not seen this before, we're using base model, which is part of Pydantic, in order to help create our data classes and be able to validate them and keep them all nice and sane. Also means we can nest models inside models quite easily and have a clear understanding of where everything is. So we've got our register request. The register request will have an agent ID, could be the host name of the agent, or it could be an ID that we just make up. Anything that's kind of unique would work. The host name, kind of, let's have a DNS name for our agent if it's required. Given that some stuff will be talking to it, we're hosting containers after all. A container's going to have a published port ID, and therefore we need to know where to send the traffic when it's hosting a container. So we will need the host name at some point. The capabilities are then the agent capabilities, which for now are going to be the CPU cores, how much compute does the agent actually have available, the amount of memory in gigabytes that's also available for us to run containers in, and any Docker networks that we happen to be running. So we're not really touching on Docker networks yet. That's more of an inter-container type thing. But the CLI that we're going to be using, the nerdctl, tells us what networks are around, so we can include that data straight at the beginning. And then we're going to report what nerd control version we are running as well. In the future, if we replace this with the agent specific stuff, then it's going to be the agent version rather than the nerd control version. We might not need some of this, which is why it's optional at the moment. So once we've got our agent registered with the API, with our agent, the hostname and the capabilities, the API then knows how much It knows that we've got an agent, and it knows that it's got CPU and it's got memory. Therefore, we can start hosting containers on it. Great. So the agent's going to talk to the API, register itself. It's then going to get a registration response, which will be a success, true or false, a message. The message probably empty if it's true, and false, it'll give us some clue as to what went wrong. And then we get onto the poll interval. So there's many ways that we can distribute data around the place. We might go for something like a queuing system, where we could use some queues or a publisher subscriber model or stuff like that. But given that the API is used to taking requests, and the agent needs at some point to provide a heartbeat. Now, if it's given a heartbeat anyway, it's going to be calling the API with that heartbeat on a regular basis. So we might as well have a poll interval that says, hey, agent, go talk to me in 30 minutes time. This is what this is basically saying. Sorry, 30 seconds. So once it's registered, it says, talk to me in 30 seconds time, and I expect you to synchronize with me, which is great. That's just what we want, because then the API knows that the agent is still alive, if nothing else. Okay, so that leads us on to a sync request. So sync requests from the agent to the API. We're reporting the agent ID so that it knows where it's coming from. A timestamp, just so that we can timestamp various resources that have changed. And speaking of resources, here they are, and it's the agent resources. So what does agent resources look like? We can see that up here is agent resources, and this is the stuff that's being used. So the CPUs that have been allocated, the memory that's been allocated, and how many containers the agent is actually running at that point. And then, as an optional bit of information, should we have it available, we can send it the load average, so we can tell whether it's a spike or whether it's running hot, and we might need to cool off on what we're throwing at it for a bit. Also in the sync request, we then provide containers, and so this is going to be a list of containers with a container status. Let's see if we've got container status. Here we go. So a list of these. So we've got the service ID. So this will be the identification that we have for essentially a deployment of containers that we have running. Collectively will be called a service. Then the container ID, which will be the ID of any container that we're running with this status. The container name, if it has a separate name. We don't necessarily need a name and a container, in the same way that when you run a container on the command line, you can just start the container. You don't necessarily have to pass the name flag. Then we want a status, which is going to report a container state. Let's just have a look at what that could be. Here we are, container states, running, stopped, pause, or restarting. And then we've got a health state, which defaults to unknown. We're not going to be using that at the very beginning, but it can have healthy, unhealthy, starting, or unknown as the default. Then we've got the ports, and this is kind of the ports that it's using. So it will be what the application is listening on inside the container, and then the externally hosted port number that we are publishing that port on, so that we can talk across the network to that container. So if it's hosting something like a web server on 443, then we can map that to a port on the host, which is then it's going to be randomly chosen by the system, and we can report to our API what that is, so then it can route traffic to it and things like that. We're then going to say what its CPU usage is, and the memory that's being reported by the container, what time it started, and any error messages if indeed there are any. Okay, so that's a list of all the containers that are in a status that we can report. And eventually, again, this is an optional thing, so we're going to add this on later. This will be nerd control events. So nerd control can talk to container D. Container D can report events like this container stopped or crashed or ran out of memory or something like that. So we will need that eventually, but not right now when we're looking at the auto healing stuff. Great. So that's what the sync request looks like. That's what we send to the API. And then it's going to respond back to us. It's going to respond back to say, was the synchronization cool, true or false, successful? And then it's going to send us a desired container list. And this is a prescriptive list of what the API wants this agent to run. So like a declarative manner. This is easiest for us to manage because we report to the API what we are running, which is this list here. It then sends us a list back of this is the containers I actually want you to run. So the container config is going to be quite similar to the container status. We've got the service name, we've got the state that we want the container to be in, and so this can be stopped if API wants us to stop the agent. Then we need the arguments that nerd is going to need in order to start that container, like the image name, the tag, the port that it internally listens to, the environment variables that it might need, if we're passing configuration into the container, the resources, stuff like the memory and the CPU that it wants, any volumes that we need to mount. So we'll come back to those later. At the moment that's probably going to be an empty list right now. Any networks, again, networks are going to be something that we need to add in later. A health check, which is optional at this point, so that the nerd can calculate or work out whether the service is healthy or not, which is important if we want to stop sending traffic when it becomes unhealthy. A restart policy, another command line option, is going to default to unless stopped. Some labels, should we want to apply labels to the container. Command, if we actually need to override the command, that's the default command for the container as well. And the workdir, if we need to override any of that, but that's optional too. So that's what we're sending to the sync request. The config is what we received back. That's where I was. And again, the API is going to tell us when the next poll interval is. So when the API expects us, or this node, to check in to make sure that it's healthy and get its latest config. So if nothing much is going on, it might sit at 30. If it's quite a busy cluster, then we've got the option to change that to 15 seconds or 5 seconds or whatever we want really. If we've got a lot of nodes, or if this node is particularly busy, then we might not need it to check in so often. Then we've got a global config, just in case we need to provide some sort of configuration to the node. I don't know what that looks like there, but it's always useful to have. And a timestamp of when the request comes in. That's so that we can have our own internal list of when we got this list of states. We know when we got told, and then we can react to that, start, stop containers and that sort of stuff. So that's what we want the agent to look like. There is also an unregister endpoint that we will have when we're closing down the agent, but I've not included that just yet. I don't think we really need much other than it'll be the unregister request and the agent ID, and then it'll get drained or whatever. We'll think about that at another point. Great. So that's the models. So we now need an API client for our agent to talk to. And so here's the calls that we're going to have. We're going to have register agent, unregister the agent, and sync the agent. That's the three interactions that we want with our API. And because we're doing test-driven development, this is very useful because we're going to be using a little bit of AI. And if we write some tests first, or get AI to write some tests, we'll see how that goes. We can then ensure that when it writes code, that the tests pass and all that good stuff. And in theory, it makes our lives a bit easier because we're testing it against known test cases. Talking of AI, let's talk about it, shall we? So you might have noticed that I'm in PyCharm, which is based on IntelliJ. It's my tool of choice for doing stuff and things. And it comes with, these days, two options for AI. One is AI chat. So this is like a regular chatbot. So if you selected it to be Claude 4, then you can ask it a question and it will answer the question like you would on a normal chatbot. But this will also send it context based on files that are open. In here we've got the test client file open, but I can also highlight it and it will say, okay, it's just that section, and send that along to the large language model in order for it to have a better context of what we're talking about. And that's quite undestructive. Not sure if that's the right word. Anyway, there is a beta option for it to modify code, but it's currently in beta. Like I said, if we really want to go to town and modify code though, we've got Junie. Now Junie can do all sorts of stuff. As it says there, delegate your tasks, focus on the results. So Junie is a bit cleverer than the AI in that it will come up with a summary of what you've asked it to do. Then it will come up with a task list, and then it will work through that task list. So you can tell it, I want you to do something. So let's give that a go now. I'm going to do a quick commit here though, because I moved these from somewhere else. So update. Oh, we need to do something else before Junie will be awake. Actually, he is awake. Update location of agent. I've just moved it from the top level inside the components folder, so nothing particularly exciting there. But what we don't have, so we've got a project toml set up, which is quite standard in if you're using Poetry or UV or something like that. And so in this case, we're going to use UV. And we've got a dependency of Pydantic. So what I'm going to do, we don't want PowerShell. No, nasty. Open git bash, that's much nicer. So I'm going to change into our components and agent folder here. And then I'm going to tell UV to sync, which will create us a virtual environment if there it is, catches up. And then because Junie requires it is actually Python libraries, so it needs Python for it to work. Now fortunately I've got other installations of Python on here that I could use, but I'm going to tell it to use this folder here. Sorry for the mess here. Jigsaw, Chaz, components, agent, venv, and then I have to go find Python, which is here. Open that up. That should all work nicely. Okay, and so now it says, hey, yep, we're talking to Chaz. We're in here. We are Python 3.13.1. Junie can now run with that stuff. So what should we get Junie to do? Oh my god. I'm going to say what we need to do is we want it to create our actual client. And when I say client, I should say agent, really, shouldn't it? We're talking about the agent, but we're talking about the API client, which is why I've messed up my words here a little bit. So we've got our main file here. Hello from the agent. And we need in here to initialize the API client, which will be in here. Now, if this is a class, which it probably should be, let's set this up as a class client. Lovely job. And then that's going to have in it an init function, which my editor has quite helpfully thrown in there for us, and then these will be inside the class. Cool. Now they're just complaining because it should have self in there because it is a class. Now you can let AI create stuff from scratch, or we could ask our AI chat to create something, which would be relatively safe to do so. I don't know if you've ever used a chat before, but it can be quite excitable. What I mean by that is very agreeable, very wanting to please you to a fault, which means it can go over and above what you actually want it to do, and it might go off on a complete tangent and really skew, what you're trying to achieve with your project. So what we want to do here is go get a client. So client equals API. What did we call it? I've forgotten already. Normally I wouldn't call it here. I mean, if this is a class file. Okay, tell you what, I really don't like having stuff inside the init, so I'm going to create a new file and I'm going to call it client.py, which can host our class. That way the class and the file name match up, and that makes it much easier for us to follow stuff. Okay, so we want a new client. Now it's found it in here, but I can notice a problem straight away in that it's going right up to the top level. Now this is because my editor is trying to be helpful, and in fact when we're running this in the context of everything else, it's actually going to be at this level where it needs to run from relative to this main class here. So we can fix that now, because otherwise that's going to give us a problem later. If we go in here in the project, in the structure, I can then tell it, it's not very good at doing this, it's horrid, but bear with. What we need to do is kill this and then add a content root and point it specifically at our agent folder, like that. And then while we're here, I might as well create one for the API folder as well. And so this view will change in a moment, where we will lose sight of all of that. But in here, see, right away we should have a source folder, I'm thinking. Because I've got my tests at this level, this lot should be under a source. I suppose we could have two folders that are sources. It just feels a bit messy to me. Anyway, so there we go, that's changed the view like I said it would. Yeah, I think I'm going to create a source folder under here actually. So we want a new directory, we're going to call it source. This lot can go inside it. Then my editor's going to do God knows what to the paths, but that's okay. And then main is outside of it because it's just going to grab the source and then do its own thing. Cool. All right. Let's go back into the settings a minute just to tell it that our source folders is not there and there anymore. It's actually here. Right. So what's that going to do for us? It means that it's going to, in theory, be able to complete stuff like that, which is lovely. Now, why does it think that that's gone wonky? I didn't even move the project folder, did I? What's it using now? I think it's the same one. Yes, that is the same one. I don't know why that message came up. Anyway, okay, so it's a little bit more helpful now. So we've included that. We're going to initialize the thing, and then we will make sure that that works. So if we go to the client, right, that should be empty. Good. Go to the client, and there's not much for it to do. It's just going to provide us back with a thing. What do we actually need? So when we start it, it's going to need stuff like, needs to know where the API is, for starters. So we're going to have the API URL. Yes, it's already trying to help me with something useful. That's not terrible as a suggestion, but we want to be able to pass it in from this level so that we can get it from the environment or something like that. So this, of course, we're in a class, so it's going to be called self. Good. There's our first thingy for the client. Cool. So when we initialize it, we want to make sure that whatever we pass in as the API URL gets passed and set as the API URL. Sounds pretty straightforward, doesn't it? So we can tell Junie to do some code, and we're going to say write, or let's say complete the test client init test. That is a test. That's already a test, right? It should check that the API URL is set when passed to the constructor. Okay, let's see what it does with that. It's going to either be wonderful, or it will crash, or it'll come up with some really good code. So first thing it says is I need to go look at something. So I want to look at what your client pie actually looks like. And that's handy because we already know it's got the right context of what it's testing. So I'm going to let it do that. It's now analyzed it. Now I don't know if it's spoken to the LLM at all at this point. I think it has, but I know for sure it's spoken back to JetBrains HQ about stuff. So I think they run their own AI type interface, and then for doing the actual like code and stuff, it then gets passed out to whether their servers are running the actual LLM model. So it now wants to look at something else. So it's going to have a look at the test file. Because this operates slightly differently to the AI chat, it doesn't get a copy of any of the files. It just needs to go look at it. So now it's telling us that I'm going to update the test client. So we approve that, and here's the code that is dropped in. So this looks reasonable. It's going to import the client, open a new client, and assert the API URL is the default. And then we're going to do it with a custom URL, and then it says client with custom URL, client with a custom URL, and then assert that that is set there. That sounds reasonable, doesn't it? So what's it going to do now? It's actually going to try and run the test to see if the test passes. And funny enough, it failed. Now that's just because I'm running, but it doesn't go to the git bash directly like this. It's trying to run it in PowerShell, so you can't do that in PowerShell, those ampersands. So it's just going to run it again, but this time put a semicolon in there. Yes, I'm on a Windows machine right now. I'm very sorry about that. But this microphone doesn't like my Linux box very much. Okay, so it says it couldn't be executed because PyTest is not installed. Well, that's a jolly good idea. So it's going to look at the project toml file now, which is here, and it's going to discover that PyTest isn't there. So let's see what it does. Right, it's like, okay, that's fine. And that's probably going to tell us that everything worked. It's like a test could not be executed because PyTest is not there. Right, well, that's fine. Let's add PyTest. So uv add pytest --dev. And so now it should appear here. There you go. Lovely. And it's installed it into our environment as well. So if we look in here, yeah, we've got PyTest in there as well. Cool. So that's in the right place. So what we can do is we can say check the test passes. And we've already got the context of this conversation. So it now should try and run that test again. It's going to try and do it with the ampersand for sure, because for some reason it can't remember that it's not on Unix, and it'll just try and run it again. So it's just going to get the context again. So, you know, it's a bit vague with my context, but it's having a good look around. Of course, there are options where you can say, hey, don't worry about asking me, just go for it and run all over the place. I'm not quite that brave enough with it just yet. Right, okay, so it's having trouble talking to the brain, and this means it stopped. Okay, not to worry. What we will do is we'll bail out of that for now, and I'm going to go, well, we were in agent, aren't we? So we can do uv run pytest -vv, and it's the tests folder, and it comes back and says there's no module found called API client, which is amazing. Not what I wanted. And that might be because we need an ini folder in here, because it doesn't identify as a Python module, and therefore we can't use dot notation with it. So let's see if that works again. Nope, it still can't find it. So this is going to be the pathing thing. Oh, right, okay, so source, we're in the source folder, aren't we? So let's open up the test, and yes, sure enough, it's not using source on the front, so that's more than likely what it's going to be. So from the test folder, it needs to go into source before it can get to the API agent folder. And there we go. And now the test has passed successfully. Now I don't know if I'd necessarily have these in the same test, because what if this fails and this fails? Then one test fails, but then it only fails halfway through. You might want to be a bit more granular. So I think I'm going to do that. So firstly, let's move this out of the way because it's bad practice to have it in the middle unless you really want it in the middle. And then we can have a test client in it with defaults. And then we'll do a dev test client in it with a custom URL. And again, it's helping me along there. So that's both of those in there. And now if we run our suite, oh dear, now it's saying that the source isn't found. We didn't change folder or anything. How is that possible that it works from here but not from here? Man, this just confused me sometimes. Yeah, so let's make sure that they got valid Python names. Yeah, it says no module name source, which is really strange because if I move it down there, it will probably work. Well, just for giggle, no. We're in the agent folder, we're in tests. I don't understand why that broke. Let's put it back. Just because it doesn't make sense that that didn't work. Sure. And so now the first one passed, but the second one failed because this import statement isn't in the scope. Yeah, see, that doesn't make any sense. I don't want to duplicate that in the other test because there's no good reason why it should need it. Why it shouldn't work at the top level is currently beyond me. Yeah, you're probably shouting at the screen saying, oh, it's because of that, Neil. Why does it work there and not there? I don't think there's any particular magic between the two locations. I mean, there isn't any at the top level, but then why does that work as a thing? One moment, please. I'm going to ask AI again because it usually has some pretty clever ideas. Module not found error for source. Now it does have access to code base, so it can read everything within this project. Yeah, so it's stated to bleeding obvious. Source directory doesn't exist in root. I can see that your client is actually located in source client, but when you try list source, it says directory not found. Add the project root to the Python path. I'd rather not do that. Or configure project toml to include the source directory. Now that's a much better idea. How do we do this? Blah 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 blah. Setup tools. That's a really strange way of doing it. Or run pytest with the correct Python path. Option 1. What was option 1 again? Add project root. Here. Yeah, I don't see why it needs that if that's there. Let's give it a bit more context to see if it happens. If it comes any other words of wisdom. The important works at the test function level. It suggests the issue is with the module level import at the top of the file. A different working directory when the module is imported versus when the tests run. Move the import inside the test functions. Yes. I'd rather not do that because it duplicates it. Do a try and then merge it in. Okay. Or use a fixture to import the module. That's an odd idea. Yeah, I'd rather keep it at top level. See, it's what it's telling me here is, standard practice is when the import is at the module level. But its explanation says that the Python path issues when the file is loaded. But when we run it, I'm at the top level here. I mean, I could do something slightly mad and go cd source and then run the tests specifying that. Nah, see, I didn't think that would work. No module name source. And yet inside the test it works. What the heck? Okay, let's try doing it this way. So IntelliJ also provides built-in support for PyTest. Hooray! Which means it might do some amazing stuff for us. So we're not in bin, we are in a agent, yes. We're in components agent. And we're going to run PyTest. We're going to do -vv because that gives us lots of stuff to output. Then I'm going to pick a folder. It should be that one. Yes. And apply that and run the tests. Yes, so they still oh, sorry, I messed that up. And this, of course, is not a script, it's a module. Of course it is. It even auto-fills it when you type the right thing in. And there we go, they all pass with that. So it's definitely something to do with the working directory. But I couldn't tell you why. Great, so all the tests currently pass, and we got 2 tests for our init. So what's the next stage? Our lovely client, once it's initialized, it then needs to register the agent. So we do have a URL for that. In our other folder over here, cunningly, we look into this init file. Did I include it? Nope. I know where it is in here. So we've got a post to register and a post to sync. And then we've got an information, don't know why we might need that, and we've got an unregister, which is going to be the delete, of course. So you could argue that that could just be a post request to agents rather than a specific register, because we're adding an agent. That would be more resty, I suppose. Okay, let's do it more resty. Because we are doing an agent a RESTy kind of agent. Agent sync, that's a bit weird, isn't it? So I'm wondering if that would be more RESTy. I think it probably would be. Right, so we'll use this model for our thing. So in our test, we want to make sure that when we register, that we're going to do that. So let's get AI again to write us a test, shall we? We'll give it a massive hint here. Now we could include this in the actual prompt as well. But we need to be quite prescriptive with the prompt. So we're going to say, write the test client register test. It should mock the API endpoint and use API/v1/agents to send the register request. Okay, that's what it does. Hopefully it'll come back with something useful. It's done all right with us so far, isn't it? But it's a little bit ropey. I'm not sure if this classes as vibe coding or not, because we are really analysing it quite a lot as to what it's doing. So, like I said, Junie does come up with a plan, examine the classes, check to see if it's already here, and then go check the models, which is very useful. And then we're going to implement a test client register function. So it wants to open all of the files first, which is fine. And it's promising to run the test to verify it works correctly. So we'll see how far it gets with that. Open the test client file. Here we are. We've got it open now. Check if there's any edge cases to handle. Yeah, nice. So it's checking to see if we've got any patterns where we've used fixtures or mocks before. Because one nice feature that it does try and do is, if it's not working from a blank page, it will try and follow your existing style. This means if you're doing something really old school, let's say you've got some JavaScript and it's so old school, you've got jQuery in there, it will keep in line and use jQuery for the rest of the stuff, rather than invent something else. Right, so it's come up with our test client. It's going to patch the request post, which is fine. It's kept our comment in there, and it's mocking the response to say success measured successfully in poll interview 45. So it's looked at our models and it's understood what our return value should be and setting it up for the mock. Now, if I didn't tell it to set up a mock, it does tend to go off on some strange path. It can, like I say, it does all. It likes to write code. Yeah, I'm just leave it there. But here we are. We've got some test data. So here's the capabilities with some networks that we might not use, and then it's going to actually call. So here's our register request. So we've got capabilities, we've got our test agent, host name, and the capabilities. Creates a client, and then an unexpected argument. So that's where the code isn't implemented yet. And then it's going to verify that it get called once with the dump, and then assert the rest of the stuff. So that all looks good. And However, it says it wants another change to the client. Right, okay. So this time it's actually going to write our code for us. So if we agree that, there we go. So again, like I said, it's quite wordy sometimes. So it's done the text, which is kind of useful. And then it's got our relevant code in here. So it's picked up the fact that we've already got API v1 in the app URL, and so it's just tagged requests on the end of it. It's using a post request, and it's sending the request as a model dump, and the request is a register request, and it expects to return a register response, which it is doing so. Get the JSON and turn that JSON straight into a register response. Okay, so it now wants to open a project. Toml, what for? I don't know why it wants to open it. Apparently it says that the request library is not included. So, oh, it's decided that that code is junk, so it's taken back out. And we're going to use earllib instead. Oh, I quite like the fact that it's going to use a request library. There's nothing wrong with that. Here we go. What does it do instead? It's updated the test. What did you do to the test? I think it's probably updated the patch. Yeah, it's got an earllib request instead. See, now it didn't ask us whether we wanted to do that. Because it tries to use the constraints you've already given it. So in this case, because we didn't have the request library, and that's the chosen way it would have done it, it's like, oh, okay, that's missing. So we'll do it this way, which still works without any additional requirements, which is good because it reduces our library overhead, but at the same time, not necessarily what we want. I mean, it would have been nice if it said, hey, I want to use the request library, is that okay? Yeah, go ahead and install the request library. And when you run exactly the same command, it's not deterministic, so it may well do that. So it's run the test, but it says it's failed due to a type error. Okay, so we can actually see what that is. If we open up the terminal, it will then show us what Junie saw when it ran the test. So here's the outputs of the tests, and when it did a thing to register, it came back with an error saying this magic mock decode, and so the JSON object must be a string or bytes array, not a magic mock. So this just means that it mocked it wrong. When it mocked the request, it left it as a magic mock, so it's missed what it should have mocked, if you like. As we look at test client, we can see that when it mocked it, it mocked earl open and request, but when we actually called it, we are using request, and it was whatever the return value is, which is here. So it's expecting a string with UTF-8 encryption, when in fact we mocked it with the return value, and the read JSON dumps encode UTF-8. Actually, that looked like it should have worked. And this is why we want to use the request library, because it kind of hides this complexity. But we'll see. Now it's passed successfully, having mocked it correctly. And so now it should now look for other edge cases. So it now wants to edit something else in the client, which I'm not entirely sure what it's going to do. There we go. Oh, right, okay. It's now given us a try and exception block, so that if any errors in here happen, we're then going to catch those. and we will still return it with a response, but give us an error. So if it couldn't open the data, it's going to do that, and if it's anything else, it's just going to erase the original exception. So now, as a result of that extra path, it's now going to create us another test in order to test that particular path itself. So here we are, we've got a completely new test that says if we're registering an error, then to make sure that we actually capture that error, and then that it calls it, it still returns, and in this case we're saying that agent ID already exists, which is nice. So now it's going to run the test to make sure that they actually pass. And it did. So now it's going to run all of them together, and they all passed, and it should hand us back control now. More or less all its tasks are done. And there we go, it just gives us a little summary of what it did. So we created a test register and a thing, and that's not too bad actually as the code goes. It would have been nice if it said, hey, you haven't got request library, would you like me to use request library instead? And I would have been very happy for it to say yes on that. So I'm going to tell it to do precisely that. So we can go uv add requests, which adds in the request library. And if I now say here, we have now got the requests library, please use it for the register function. So, you know, arguably you could say it's slower because, hey, it did the request code in the first place. Rather than asking us if we want to use the request library, it decided to go, oh no, I'm not going to add any new dependencies, because adding dependencies is usually bad, but let's carry on without dependencies instead. But now I've actually added the request library. It's going to examine the thing, and now it's going to update the client. So it's probably going to put the requests in, yeah, which it has. And then it's interesting that it's going to implement the client first rather than updating the test first. But yeah, look at that, simplified that chunk of code quite a lot, because it means we haven't got to create an extra object. The request library does it all for us. It's also updated the exception here, and now it will go off and it'll update the test to match those, which saves us, you know, I could have done that. It just saves me a lot of boilerplate working. So it's updated the requests as the library. Now I'll update the two tests all at once. Blam blam. Time passes, and look at that, it's updated the first one. Interestingly, it's changed a little bit more than I was expecting. Oh, it's just updated the mock response, of course, to match what we're expecting. Now, interestingly, the mock response would have still worked because the request library uses that code under the hood. So we could have not changed the test at all, but then we wouldn't be checking the code in exactly the same way. So by mocking out the response library, wherever it is, where is it actually patching it? Oh yeah, patch post, there it is. We then get it, so the mock post is in here straight away. So if you've not done patching before, so patch tells it to patch a specific path. So in this case, it will be requests and then the function name, so requests and post. It always patches based on where it's running from. And I could do loads of videos on that, but essentially you want to make sure that your patch matches where the code is running. So if this has a request here and it's importing requests from here, then you want to make sure that requests and requests is the same location. So if it said source.requests and then the test said requests, they wouldn't work. They'd both have to say source requests. But this does say requests and then post. So it's the post function in requests, which means request is here, which is the same, and then post. So that's what it's going to be patching. Once it's patched it here, it then makes it available as an argument at this point. Now, if you've got more than one patch, they're actually backwards. So the bottom one here, rest post, will be first. If you put one above here, then that'll be second, not the other way around. Anyway, so we are about to run the tests just to make sure that they pass again. With the fact that we've got 2 patches going on there. So it now says all the tests have been updated and that they passed. We can look at peek in here and it says that they did pass. And now we're ready for a new task, which is wonderful. So I'm going to leave it there for today. I might run more tests tomorrow just to get the sync working, but that's the most exciting bit. So I suppose we will leave that for the next video. Till next time, see you later.